I will not spend time trying to describe ACCS. You have the access to the website. What I would just say that we endeavor to take messages around technology advancement, new areas of technologies, etc., to all the communities involved in this field: students, faculty, industry practitioners. Last talk was about system design, and we have taken a kind of deep diversion today by design. And today we are going to hear Mr. Deepak Sharma from Microsoft about DevOps. Mr. Deepak Sharma has 25 years of experience in IT consulting, project management, project-based startups, people management, service delivery, planning and management, and so on. He specializes in DevOps, particularly with regard to Microsoft Operations Framework, service delivery management, and the design, deployment, improvement, and transition of IT infrastructure. Graduate of Punjab Engineering College and a diploma holder in business management from Narsi Monji Institute of Management Studies. He is also a life member of ACCS, serving on its executive committee. So this talk is in-house in a sense, no bar on that. He is going to talk about DevOps and how the tools available from Microsoft has made it very easy for the software developers to practice DevOps. Over to you, Deepak.
Thank you, JK. I hope everybody can see and hear me. I'm going to transition to my presentation. If you can see my presentation here.
Yes, we can see you. And
all right. So thank you for the kind introduction, JK. And this is sort of a privilege for me to talk to the academic audience as well as the professionals at the same time. So I'm going to try and make sure that we cover all angles of DevOps, from the people who are just getting into the field of software development to the people who are very familiar with software development, and see we can cover all angles of it, right? And so what I'm going to do is just cover two agendas. Actually, my two agendas are one is to make sure that everybody understands DevOps, right? So I know there are so many courses available on how to do CI/CD. So many other software development methodologies are available. And there are so many courses also available on DevOps. So I want to give you my perspective of DevOps, of why it is important today, why you should know about it, because when you go out and start working, you're going to encounter this thing at most places. And a lot of organizations who are still not gotten into the field, they're trying to get into the mode of DevOps, and we will just try and demystify that for you. And second, what I want to do is give you a perspective on how actually Microsoft changed its culture and processes and tools to start doing DevOps, right? So how Microsoft builds software, that is what I'm going to share with you, because that is something which I believe can be of a lot of value towards you, right? So this is a slide which I'm just showing you to show you that ever since 1970s, what is the trend been, right? So the 1970s and 80s, this was the era of the mainframes, right? And the cycle time to build some new software used to be from 1 to 5 years, right? And if the project failed, the company who was doing it or the company who was paying for it could go into bankruptcy, or they have to sell the company, or this is the cost of failure, right? So this is the huge cost of failure. By 1990s, you have all the client server architectures, you have PC based x86, a lot of commodity software and hardware was available, and the cycle time reduced from 3 months to 12 months kind of time frame. And if you actually invested a lot in it, the cost of failure could miss revenue, or CIO could lose his job. So that was the kind of cost of failure. But today, what has happened is with the commoditization of each of the components available for software development and the cheaper availability of cloud resources, the development time and the cycle time has reduced to from couple of weeks to about 3 months, right? 12 weeks, right? And the cost of failure is negligible because first of all, the resources you spend are much less for much less time, and anything you build on the cloud can be just with a click of a button can be deleted everything, and there's no more cost to pay because it is all use and pay, right? So that is where you're seeing that there's constant trend towards cheaper, lower risk delivery of software, right? Now, who is doing this DevOps, right? So I deliberately, so this is data from 2015 actually, and I just deliberately took it because I just wanted to show you that this has been happening for quite some time, right? So what I'm showing you here is how these companies are doing DevOps and achieving these what we call as the deployment frequency. So Amazon.com deploy in 2015, they used to make deployments to their production environment, 23,000 deployments a day, right? And the average lead time was in minutes. So when we say lead time means from when the point when you require something to when you deploy it in production, the lead time for that is minutes. And reliability, I'm sure all of you have used Amazon websites, and how often have you seen that you get a 404 or any of those errors? So the reliability is very high, and they are able to respond to customer requirements very, very quickly, right? And you can see how it changes from, I'm not going to list down all the other companies which are doing it, but if you look at it, the comparison with the traditional enterprise, right? In a traditional enterprise means a large company who is not into software development in general, right? Who is doing, let's say, manufacturing, or maybe it's a bank, right? Those are traditional enterprises who use computer systems for doing their business, right? If they have to do any deployment, their deployment can take from 1 month to 9 months. Once in 9 months, they will do a major deployment, right? And the lead times is in months or quarters. This is maybe 3 quarters it will take some to build some software and deploy it in production, right? And reliability is low to medium. Responsiveness, obviously, if the customer today asks for something, it may take them almost 9 months to build something and deploy something, right? So this is just wanted to show you a comparison that see the difference between the traditional enterprise and what Amazon is doing, right? How many deployments and the customer responsiveness is there when they do DevOps, right? So if you have if you are studying computer science or for any of the computing software development courses, you are also familiar with the software development lifecycle, right? So what you're seeing here is a traditional model of software development and operations, which is also known as waterfall model, right? Which is you have planning and requirements and design and development and testing. Then somebody gets to deploy it, may or may not be the same people. Then somebody gets to operate it, again, whole set of different people, right? Now, of course, this is what happens, right? So this is what we call as between development operations, there is this wall of confusion, right? So development basically throws the software over the wall to operations. Operations deploys it or runs it in production, and then boom, something bad happens. So this is what has been happening for quite some time. And these models still exist in most organizations who are still operating with the traditional model. And this is, if you've never seen a picture of a silo, this is what a silo means, because you hear this term again and again. We work in silos. What does a silo look like? This is what a silo looks like. So people work in silos that there are no windows between these three silos, development and business and operations. There is no connection between them. So they are individual things, and the communication between them is very limited, right? So this is what you will hear when you go and talk to any organizations who are developing software for any enterprise, right? So this is one of my favorite slides. Is for DevOps is like that. blind man and the elephant, right? There are various views of DevOps. When somebody says DevOps, it says development is basically a collaboration between development and operations, right? And development is treating your infrastructure as code, right? Infrastructure as code is nothing but you write some code and you run it and it deploys your infrastructure. When we say infrastructure, it is your servers, your network, your storage, all those things is infrastructure, right? So all those things today are possible to deploy just using a script. So that is what we call as infrastructure as code, right? And DevOps is using automation, or DevOps is using feature switches. We'll talk a little bit about feature switches also. Or DevOps is small deployments, right? So DevOps actually is all of these things together, right? Today, if you ask me, is there a standard for DevOps? The answer is no. That is why everybody has their own view of DevOps. But if you go at the core of what is DevOps, so at some point of time, it was an emerging trend, but now it is a completely emerged trend, right? And the trend is to give more value to the customers. The flow of value should increase. The speed of the flow of value should increase to the customers. That is what the purpose of DevOps is, right? So as I showed you earlier, how much time it used to take for anybody to develop and deploy software in 70s and 80s, right? So and now considering what it takes today, if you are using any mobile phone today, you are getting updates every day for some application or the other, right? That is the expectation of your customers also, that people want updates so quickly. If you want updates quickly, can you write so quickly the software which is more reliable and does not break, right? That is what we have to consider, how DevOps makes that thing happen, right? When we say flow, what is the flow what we are talking about, right? So between development and operations, right? So development are the people who write the software, test the software, take the requirements, do all those things, which is before the software is available to the customers. And operations is what the people who run that software in a production environment with the servers, managing the data and the access to the systems, right? So between development and operations, the first way the flow is, we want flow from dev to ops to increase, right? This is the first way. This is the systems thinking approach. It has to be there between the development and operations, right? We want the flow of what is produced by development to operations to increase rapidly, right? The second is, we want the feedback from operations back to development to be amplified, to be increased, right? So we just don't want to just the example which I gave earlier, just throw it over the wall and let operations manage everything. What we want is operations should gather the feedback and make sure that development gets that feedback to improve the software quickly, right? And this third way is basically continuously there is experimentation and learning which needs to keep on happening over the life cycle of the software, right? So this is what you will see is the purpose of DevOps. So the reason I'm giving you this overview and the higher view of the things that are required from putting this all together, because other things you will learn you need to learn how to do coding, you need to learn how to do testing, right? All these individual components are still there. Let me show you how these individual components are there in the DevOps cycle, right? So what you see here is a cycle which starts from the requirements, right? So you have these requirements if you are familiar with some of the frameworks in Agile and Scrum. So they have a list of requirements which they manage in a backlog, right? Now this backlog is where you get in all the requirements, all the bugs, everything that needs development effort, right? So and then this backlog is used by the development teams, which is using all these methodologies from Agile and Scrum to create this software, right? So when you hear about Agile and Scrum and all these other software development methodologies, frameworks, they are used here to create the software, right? Create and test the software here. So this is not just development, this is development and testing. This development and testing has to go through an automated release pipeline where this is all the release pipeline, make sure that the software is tested, it is safe, all the pre-production testing is done, and there is full traceability. Traceability means that you should be able to find out what line of code caused what bug. That is what traceability means. And it also goes back to who created that bug, and so that that person can actually go and take action on it. So that is what traceability means, right? Once this software is released into production, you have all the monitoring and what we now commonly known as telemetry, which the term which comes from the rocket and the space industry, which is telemetry is when you remotely find out what is actually happening with your rocket. So this telemetry is telling the development team what is actually happening in production, so that they can find out how the software they built is actually working in production. So it is not just the job of the operations team to look at what is actually happening in production, but also the development people who build that software to actually care about it and take action when they need to, right? So they will get the feedback through the backlog. If there is a bug, they need to take action. That goes into the backlog again. The same cycle comes in, right? So all this thing happens very rapidly. This is the DevOps cycle which we talk about, right? So the important thing which you heard about is that this is a cycle, right? And we want to run this cycle much frequently, right? So what is the value of running this much frequently, right? So obviously there's a change, right? So if you do changes which take a lot of time, the same amount of change, if the quantum of change you do over a period of time, there is a much more risk. Whereas if you do in small chunks, right? You run this cycle over and over again, you do it in small parts, you can achieve it more quickly. If something breaks, you don't lose too much time, because if something breaks here, you have lost so much time and effort, right? So this is the difference between, this is how you reduce the risk of a small release, right? So if you ask what is the Microsoft definition of the DevOps, so this is what we say. This is the union of people, process, and platform to enable this continuous delivery of value to end users, right? So we have these people, right, who have to collaborate more. They have to share the common goal, because it is not just the job of operations to keep the software live or the service. If you're running a web service to be alive, it is also the job of the development team to make sure that they collaborate and make sure they are able to find faults, right? So if you ask in number of scenarios today, how you make people accountable for the software they have written, the developers are on call, right? So all the major cloud companies, all the major born in the cloud world enterprises today, they have all the developers who wrote the software to be on the call. That is the best way to hold accountability for what they have written. So if you remember, if you have to be woken up in the middle of the night if something breaks down, you will pay much more attention to fixing it while you are creating it, rather than being woken up in the middle of the night. So that is how you bring the people together and accountability, right? You need to change the process, right? So all that waterfall process where you have all these steps taking place, that causes a lot of delay. There is a lot of waste in the second. This causes inefficiencies, right? So you need to fix the process, use things like Agile and Scrum, all these frameworks which help you streamline your development processes, right? So that process needs to be changed. And of course, the platform, the tools, you need to have tools which enhance productivity, right? You need to have tools which enable collaboration and facilitate experimentation, right? So you need to have such tools. And we'll talk a little bit about those tools also during the session, right? So how do you actually measure the success, right? So there are the two things there are two main kinds of indicator which you have to use, right? Which is, how do you measure agility, right? Agility means how quickly you're doing stuff. The second thing is reliability. How reliable is what you are building, right? How do you measure agility? If you increase the deployment frequency, remember the first slide which I showed you about how frequently Amazon is deploying to production. That is their agility, how frequently they are deploying, right? And their lead time, right? Lead time is, as I said, how quickly can you come from the idea to production? That is your lead time. How do you react to the dynamic business changes, right? So tomorrow there is a sudden change in business environment. Let's say you might have seen a lot of organizations when the COVID started, they changed their websites, they changed their operations. How did that all happen? Because they were able to quickly react to the changes and reduce the lead time required to deliver some software, right? So that is how you measure agility. And how do you measure reliability? All of you are familiar with reliability, because if you open a website, it does not open, obviously this is not very reliable, right? So how do you reduce when you deploy a change and it does not fail, obviously the system is more reliable because you have tested the change before, you have done all the grind work before in a hopefully an automated way to reduce the time to make sure that this change succeeds in production, right? And then obviously not always everything works. How do you actually work with things when they fail? How do you recover, right? So first is how do you detect something has failed, and then how do you repair it? This is what we in the operations world is known as mean time to detect and the mean time to repair, which is MTTD and MTTR, right? So how do you find these? How do you measure this success? Is how do you look at these parameters, which is how quickly can you find out if something broke and how quickly can you fix it, right? So this is how you measure the success of DevOps, right? If somebody talks about it, these are the four indicators or the success metrics which you can look at, right? And there are of course some
Deepak,
myths.
interrupt
Yes.
you. On the screen, we still have this slide titled the DevOps cycle, and your picture is also frozen. So I suspect that it's not moving.
Okay, let me.
No, boss, I'm able to see that correctly. Things are moving to me.
Okay. Okay. So anybody else can confirm the pictures are moving for them?
Yes, sir.
Yeah, go ahead. I'm seeing a picture of flying angel. What I'm
Yes,
seeing right
yes. That is the correct picture.
All right. Good. So it's me.
Yeah. Okay.
now. Yeah.
All right. So what I was talking about is some of the myths of DevOps, right? So the myths of DevOps is that adopting the tools makes you DevOps, right? Right. So there's a big myth that if you just get a DevOps tool, you will automatically start doing DevOps. That as I've shown you in the previous slides, that is not how it works, because it requires so many other changes to happen, right? It is only for startups. That is not true. A lot of large organizations today, including Microsoft and a lot of banks, a lot of manufacturing organizations have started doing it, right? Of course, it is true that startups have no legacy so that they can start with new processes. It is much easier for them to do, but that does not mean that it only applies to startups, right? That there's another myth called that DevOps is the replacement for Agile. That is not true. As I showed you in the cycle, Agile is very much required. Agile is one of the things which makes DevOps successful, right? If you're coming from operations background, there is this framework for operations called ITIL, that this somehow DevOps is against ITIL or is incompatible with ITIL. That is not true. You still require operations, right? We'll talk about it. It is incompatible with security and compliance. That is not true at all. You cannot, just because you're building software fast does not mean that you can make it, you can reduce the security or reduce the compliance requirements, right? Today, if you build software for any European company, you have to be GDPR compliant. If you are building software for Government of India, you have to be MATI compliant, right? So there are so many compliances which are still required, and DevOps can still make those things happen, right? So there is no incompatibility with that, right? And some people believe that DevOps will eliminate IT operations. That is not true. There is operations is very much a necessity to make things reliable. You need to make sure that you still have operations behind a service which is there. it is just automation. As I showed you, it is not just automation. There are whole processes and changes of culture and people which need to happen, just not the tools which are related to infrastructure as code or automation, right? And this is my favorite one. It says it is only for open source software. Again, not true. A lot of not open source software is built, but that is true. Today, there is a lot of open source software available to you if you want to do DevOps. There is a lot of open source software available for all components, all tools required for DevOps. There is at least one open source software available for you to do it, and the entire thing you can do it in DevOps using open source also. But that it is not just that you need this only applies to building open source software. You can build software for any kind of organization. Right. So this is what I wanted to give you an introduction into what DevOps means from the overview of what it takes. Right. Now, the next thing which I want to talk to you about is how DevOps happens at Microsoft. Right. Now, before I get into that, let me show you a tool which all of you should be familiar with. Which is the Azure DevOps tool, right? So if any of you wants to play around with DevOps, you can just go to dev.azure.com and you can get a free account for Azure DevOps, right? So this is there. This is available lifetime free. As a student, I would encourage that if you want to use this thing, you use this thing. There is some amount of free services which are available, which you can play around with this. Now, the reason I'm showing you this specific tool is because I'm going to tell you the story of how this tool is actually built, right? So that is what I want to show you because this tool gives you all the features that you need to do end-to-end DevOps, right? So if some of you are familiar with Visual Studio, and if some of you are familiar with the Team Foundation server or the Azure DevOps service now, so that is the service which I'm going to talk about, and it's been there. This journey has started from nearly 11 years ago, right? So this is where it started from about 2010. It started from building this Team Foundation server, which was available as a standalone server deployed inside your organization, to now running as a service, which I just showed you at the web page of, which is the Azure DevOps service, right? So now it is available as a full-fledged service. So this has gone on for more than 11 years now, right? So this tool is used internally by Microsoft. So all the software which Microsoft builds is built using this software, right? So I'm just showing you how many people inside Microsoft use this thing over a period of from 3 years. What you see is the two types of users. You have both engineering users. When we say engineering users in Microsoft, is basically software engineers, and non-engineering users are all the people who are not directly involved in building software. They are the non-engineering. You can see more than 90,000 people actually were using it. This is almost 2-3 years old data. Now this has gone to more than 100,000 people who are actually using this software internally to Microsoft, right? So besides this, there are millions of users who use this software. So what I'm trying to show you here is this product is built using Azure DevOps, is built using Azure DevOps. So it's a sort of a example of software building the same software, right? So this is what we learned, right? This is what we learned while trying to build this software, right? So one is you have to be customer focused, right? The second is the production first mindset. We'll talk about, I'll give you some examples of what does all these things mean, right? And how does the team and enterprise alignment work, and the shift left in quality. We'll talk about these things. So what does really customer focused mean, right? The first thing is to listen to your customers, right? So how do you listen to your customers? So of course we have direct feedback. So if you look at any Microsoft tool, there is the feedback is actually built into those tools, right? If you click on those things, you will get pop-ups. If you're using Teams today, at the end of the meeting, you will get a question mark on feedback on how the meeting went. Did you hear the voice clearly? All those things, the feedback is built into the system, right? So we get feedback directly. We monitor Stack Overflow, right? We use all these data is collected and managed and make sure that we have people assigned to work on all these. So this is where you are seeing there's an example of, if you within Azure DevOps, there is a tool. This is report a problem. You can just directly go there. It will log, and directly the people who actually build that feature, they will get the feedback directly, right? So that is what we mean by when say focus on the customer, because we want to know as quickly as possible what happened there, right? So in Agile and all these frameworks, you will hear this term called definition of done. When do we consider that something is done, right? So when something is done is when it is live in production, when it is collecting data, which is what we call as telemetry, and it examines the hypothesis which motivated the deployment, right? So what is this hypothesis? So this hypothesis is we go with the hypothesis that we believe that so and so customer wants this feature because of certain value which the customer will find this thing. So when you create this hypothesis, you will do an experiment that, okay, to prove or disprove, we will create this experiment. So when we say experiment, it is number of times when you go to a website, you will say, click here. Even if you use Facebook or Gmail or any other software, it'll say, click here to try the new interface, right? So that what all organizations, well, they're doing is they're doing an experiment. They're trying to learn directly from the end users how they feel about this feature. So that is what the experiment is there. And then there's always a thing, we'll say, okay, turn it back to the classic mode, right? What does it? That means that you did not like it, or for some reason this new feature is not working for you. That is what this hypothesis experiment means, that they will measure it. They'll see how many times the people tried this new feature, how many times they went back to the old one, and they learn from these experiments, right? So this is what also called as testing in production. But these experiments are very carefully designed. These are not just random experiments, but this is what gives feedback to the software developers to give them confidence that what they're building is true or is good or not. The second thing which they do when they build some new feature, what they do is they put it behind a feature flag, right? So whenever you try this new interface or new this thing, they will enable this flag for you as an end user. It says, okay, this user wants the new feature, turn on this flag for it. So the user uses that part of the code, right? If you do not want this thing, you can turn the code off and says, okay, it will bypass that new feature and then the code will just pass. This is what the feature flag does, right? So if you turn the feature on or off, it will use the code which you put it in there or not there. So everything now which is being built and deployed to production, they will turn it off by default. They will turn on by certain segments, right? And they will turn it on by, so this what it does is it provides this runtime control to an individual user, right? If you are building software today, this is something which I would say enables you to turn on or off the feature without actually redeploying the software, right? So this is a progressive experimentation and refinement option, which actually is a key part of DevOps, because you don't want to, just because you built a new feature which developed a problem, you have to undeploy and you redeploy the whole software again. Instead of that, what you do is you put it behind a feature flag. You turn the feature flag on. The feature is on. If you find there's a problem, you can turn it off, right? Without making the production system to go down, right? So this is what they call as enable a dark launch, right? If you're looking for some example of a software, there's a whole software company which is called Launch Darkly, which enables this feature flag option for your development. right? So that is a tool which you can use to control the feature flags there, right? So when we say production first mindset, what does this production first mindset mean, right? So production first mindset means that we have to care about what happens in production, right? So we cannot wait for somebody to report it. We have to constantly be available to make sure that there is software developers actually who actually build the software are available on call to fix it, right? And they are able to gather the repair the data, get the logs in the quickest possible way to make sure that these live site incidents, which are called within Microsoft, we call them live site incidents, to be reduced, right? So they want to be, this is DRI again, a lot of acronyms are there because Microsoft loves acronyms. So we have DRI is a directly responsible individual, right? So he's the person who is responsible for to be on call on that for that feature, right? So this is what we call as building this live site culture, right? So you have these people who are monitoring, making sure that your site is always monitored. There is a review. They are making sure that they have actionable alerts, right? This monitoring is all about actionable alerts, right? And they have reviews for on monthly basis how they are going to improve the service. So they are directly connected to the application development team rather than sit inside operations, right? So other thing which we have done is we are transparent. If something goes down, we publish the root cause. So this is just an example of screenshot of what happened when we deployed a patch which caused an outage. So this is where we commit to giving our users the information so that we are accountable for what we are doing and bringing things into production, right? How do we make all these things happen? Now this is the interesting part of how we change the culture within Microsoft of this team autonomy and making sure that they still work for the organization's benefit, right? So if you are interested in a book which defines this, what is the motivation factor for people, right? So there's a book called Drive. So what just in one sentence, what they say is what Daniel Pink has written is that if you give people autonomy and you allow them to master the thing which they're trying to do, and you give them purpose, they will automatically start giving you the output which you're looking from them, right? So for us, obviously there's the organization, there's the roles, the teams, what frequency, right? So there'll be the taxonomy is just the name of roles, all those things have to be there, and there are plans and practices, right? So each team gets to decide how they want to plan it, what practices they want to use, right? And all this alignment is coming from the organization. The structure is given by the organization, right? So before we went into DevOps, we used to have these teams, right? Which is one is the program management team, the team which does all the part where what should we build, what does the market need, and all those things. And you have this development team, which is the engineering team. Then you have this testing team, very large testing team we used to have. And of course, there is operations. And if you are from operations background, we look at the operations is the biggest thing, and the other things are small. But so what we did was we actually merged all the three roles, which is all these development, testing, and operations under one team, which is called the engineering team, right? So this engineering team is actually consists of what we call as feature teams. Now, so each individual part of the software is considered to be a feature, and this feature is built by a feature team, which is a cross-discipline team. What does a cross-discipline team mean? That you have UI, UX, you have database, you have coding, testing, all those people with all the things which the team needs to build the feature. They will be all part of one team. So there is no handover from this development team to that development team to test it, to give to somebody else, right? So there are about 40 feature teams, right? And within the 500 people team, there are 40 feature teams. So this is an autonomous team. They have their own backlog. This team remains intact for 12 to 18 months. They are self-managing. That means they decide how and when they will build what the feature which will be done, right? In parallel with the program management team, right? So program management team puts what is the priority. They will pick up and start building the software, and they are responsible for keeping the software running in production, right? So this is what happens for a feature team, and this is something which is unique to Microsoft, which is we have what is called as a self-forming teams, right? So this self-forming teams, what we do is, this is what we're seeing is actual picture of an exercise which we call as a sticky note exercise, where people get to decide what feature team they want to work for, right? And then they do the sticky note exercise. They give their options as to this is my first priority, this is my second priority, and so on. And then they get to work for that team, right? So what does this give is the opportunity to change the team without formal interviews, and there is no top-down reorganization, right? So employees is given the choice. It is not manager driven, right? So this is a unique approach, right? Typically what we have seen is less than 20% people change, but 100% get to make the choice, right? So 80% of the people remain with the team, but it creates this opportunity for everyone to learn new things, right? Which is cross-pollinate with talent and whatever, and things which you learn from one team, take it to the other one, which you call as microculture within the teams. So this cross-pollination happens, and that is what increases the productivity. And that gives the motivation for the team to work for. This is what they want to work on. This is not what they are being forced to create. This is what they are choosing to create, right? So when we say shift left in quality, what does that really mean, right? So this is when we said you create this pipeline of things going from dev to test to release to production. This pipeline, right? How do you go fast and not break things, right? So this is something which happens, right? So if you are trying to do something very fast, there's likelihood that you will start breaking things, right? So what you might have heard this thing called technical debt, right? So technical debt is something it's a compromise which you make in your build when you are building your software, which you will have to pay in future, right? It's like you could use 16 bits, but you decided to use 8 bits, but because for whatever reason they said, okay, later on when I need 16 bits, when you actually need 16 bits and decide to use 8 bits as a compromise, you are taking the debt, right? So that's what, and any bug is also a debt, right? So you're deliberately taking that debt, right? So what we have done is to make sure that we do not incur debt, we follow a simple rule, which is called the bug cap, that for any team, multiply by 4, the number of engineers multiply by 4 is only the maximum number of bugs which you can keep in a. So if you have a 10 people team, only 40 bugs can be kept open in any state, right? So right. So I know this just about 1 hour, and I'll probably take another 15 minutes to finish this presentation. Is it okay, JK?
It's fine, Deepak, go ahead.
Please go ahead.
Okay, so if you've ever used GitHub or any Git based repository, so there's a pull request. So what we have done is we have all the testing, as I said, is automated, right? So every time there is somebody checks in the code is done. There's what we call as the shift left testing to pre-merge, right? So there is the code is tested before it is merged into the master, right? So if you're familiar with the how Git branching works, so if you take a pull request and if you're taking a branch and you're trying to merge it into the master, you raise a pull request. Before your code is actually merged into the master, it will go through automated tests to make sure this software is good. We do all this on all pull requests. There is this automated testing done, right? So tests against pull requests are done. So if I can probably zoom in, this is from a real screenshot of what is being built. So you can see how many tests are run every time there is a build, right? So you can see there is 78,000 tests which are being run every time there is this pull request run, right? So you can imagine that. So if any software which is being built with so many tests has to be much more reliable than something which is tested in production only, right? Or being fully built. So this is, I will show you a little bit more around testing of what kinds of tests we are doing, right? So only the green builds where you are seeing these builds are actually, these are the series of builds which have to be done to pass, right? So only the builds which are passed through all green, only those make it to production, right? So what are the kinds of tests which we do, right? So these are what we call as 4 different types of tests which we do, which is from L0 to L3. So L0 is basically the unit test, something which you can done. So if you're familiar with software development, this is unit testing, which requires only built binaries. There are no dependencies. You can do it while you are compiling. Just after the build, you can run these tests without actually requiring the system to be deployed, right? So this is L0 tests. So this is the cheapest and the earliest possible test you should be doing, the unit testing, right? L1 is something which requires a little bit of dependencies like SQL Server or a file system, right? So L0 and L1 are the tests which we run every time. Those 78,000 tests which you saw, these are the tests which are run, right? So if you want to know how long does those 78,000 take to do? So on my last check, they took about 6 to 7 minutes to run all these tests run, right? So all these tests are run in parallel on servers. So these are, of course, high performance servers, so they can run in so many tests in parallel. But the important thing is that these 78,000 tests are run every time there is a pull request, right? And there are number of pull requests in a day in the numbers of hundreds, right? It's hundreds of pull requests in a day. So that is the effort which is being spent on making sure that the software is reliable, right? Level 2 tests are tests which require the REST API, which requires the deployment to be done in some environment. Level 3 tests are full end-to-end tests, right? So if you're looking at this graph at the bottom, I just want to zoom in a little bit so that you see this example here, right? So this what you're seeing here is this blue is the L0 test. So when we started transforming our testing, we had very little L0 tests and lots of these L3 tests. L3 test means these full environment end-to-end tests, right? These are the most expensive tests and this is the most unreliable tests because they cannot possibly test everything. So over a period of time, what we started doing was we started increasing these L0 tests and started decreasing these L3 tests, right? Oh, and now mostly we have eliminated all these L3 tests. They are done only in production, right? Only in production. The L3 tests are only done in production. Rest everything is done within the build cycle, right? So that is the level of confidence we have reached that we can actually deploy to production because we have so much trust in these L1, L0, and L2 tests that we don't really need to do this full end-to-end tests until we hit production, right? And production also, there are so many ways you can control the so-called blast radius of anything so that you deploy it in first. of course, since we build using this software, it is deployed to those people, and then so on, it slowly get released to the wider and wider audience, so that you can control how if something needs to be rolled back, it can be rolled back quickly and automatically, right? So this team, they build this software. Now we still have the, if you want to deploy this software onto your own premises, you want to deploy Azure DevOps server, the code base is same. So they use the same code base to build. So this team actually runs a 3-week sprint. So they deploy this server and features into production every 3 weeks. So their sprint is 3 weeks. They put it into production every 3 weeks, right? And every once in a while they will bunch this thing up into an update which goes into the server version, which can be downloaded and deployed into your own environment, right? So this is what they have done, right? So what is the transformation they have achieved? Earlier they used to have these 4 to 6 months milestone. Now they are deploying every 3 weeks, right? They used to have these horizontal teams, which now they have vertical teams where each feature is owned by them, right? So many other things are there. We can go into that. But the main thing which I wanted to share with you is that they are now shipping. They used to ship once a year. Now they are shipping every 3 weeks, which means they're deploying real features into production every 3 weeks, right? So that is what they have achieved. So if you were to look at the summary of what actually happens inside DevOps, this end-to-end DevOps cycle, right? So you have this plan, develop and test, then you do release, and then you do monitor and learn, which is so this is the development, this is operations. So going a little deeper into that. So your project starts, you do plan, you manage the work using whatever framework you have, agile frameworks, right? You track the progress, you do the development and testing. That is then you go into development and testing, right? So you write the code, you do the unit testing, you do version control, you do build verification, you go into release, right? In release, what happens? You have automated functional testing, you have integration testing integrated testing environment, which is automated. You have this pre-production environment. You do load testing using automation, cloud load testing, right? Then you deploy to a staging environment, and then you can go into production for monitoring and learning, right? So, and when you do the monitoring and learning, of course, you do get the feedback, and then you plan your next iteration, right? So that is what happens, right? So this is when you look at the continuous delivery and deployment. So these are the different phases of what happens between the delivery team. The delivery team checks in the version control. They do unit testing. If it fails, it goes back, right? Nothing goes to production because the build failed. If it passes the unit test, it goes to automated acceptance test. If it fails, it goes back again to the development team. If it passes all these stages and you get the approval to deploy into pre-production and approval to deploy in production, that is how it moves forward, right? So if you were to think about starting to do DevOps, right, you have to pick the right project for pilot. Make sure you understand who the owners of this application are, right? You have the right access to all the data which is required, right? You get the right people on board, right? Make sure that you have people from development and operations and data and business. They form the team so that they work together. Then you get these right tools, and Azure DevOps is one of the tools. There are so many other tools available which you might have heard of. There is Jenkins. There's other components available for different tasks within DevOps, right? So this is what I wanted to share with you in about 1 hour. I went about 10 minutes over. So at this point, so if you are interested in getting more information about how Microsoft DevOps, Microsoft does DevOps, and there are so many stories around how we do things, and we are openly sharing them across our websites, and a lot of people talk about it. You can even find those videos on YouTube. You can go to this link, which is aka.ms/DevOps. Right. So this is what I wanted to share with you today. and I will take questions if Prashant, if you have received any questions on chat, I will take them to answer first, and then we can go further.
Live with it.
Yep, thanks, Deepak. That was wonderful. We will take questions now. So you can put it in the chat, and we will allow you to unmute, and you can ask your questions directly to Deepak.
Have you received any questions so far?
There is one. I think Balu, are you there? I'll allow you to unmute.
Yes.
Yeah.
Okay.
You can go ahead, Balu.
Can you hear me?
Yes, we can. Go ahead.
Firstly, thank you, Deepak. This was a wonderful session. I did really enjoy listening to the stories of Microsoft. So a couple of quick questions, Mr. Deepak. Can you share a little bit real-time challenges of the DevOps in the industry? What kind of challenges would typically people come up in a matured organization? I'm not talking about something which is like just adapting. I understand that.
Yeah.
Right, more in larger organization, or somebody who is already matured.
Yes. So you see, there are a lot of issues which happens in large organization, and I work with very large organizations to help them make that change. One of the things is inertia, right? So the biggest problem is inertia, because people, they are used to a specific process, right? They know their old software development lifecycle, the planning, the taking of requirements, writing these big documents which describe requirements in detail. That is the biggest hurdle for making that change, right? So, okay, so let's say somehow you convince the dev team to change this. Then the difficult part now becomes, you have now all this while you have trained the business to work with in a certain way, right? You told them that this is how we work. You have to give us requirements in detail, and we will write these tests, and you have to participate in this, and it'll take 6 months to do it. Now you go and tell them, now we are doing agile and DevOps, and we will give you software much more quickly. So in the mindset, what happens is, now business starts thinking, oh, these guys were all this time, they could do all this work in 1 month, which they were taking 6 months, right? So that mismatch of perception happens. So that is the biggest challenge. What I've seen is business starts, one is, first the software teams start giving the wrong message to the business. It says, oh, we can build, now we are agile, we can do all these things. And the message which what the business gets is, oh, we can this is agile, we can change our mind whenever we want, right? Today we want this, tomorrow we want that, we can do all those things, right? And that is what drives most of the things to, then that is where people fall back and says, okay, no, we cannot do this. Then business gets decision, oh, you are still back to doing what you were doing earlier. So that is what we have done is, if you need to do something like this, you have to bring business on board into understanding that this is something which requires effort, requires some change management in terms of making people understand the process has changed. The tools themselves are easy to change. Actually, they are not a challenge. Today, you get hundreds of tools available for you to do DevOps, including from Microsoft and open source, right? So that is actually the least of the challenges. Any problem you have today, there is a tool available for that. The problem is the culture.
Thank you.
Anybody else?
If not, I'll continue. Okay, sorry.
I have another question.
Yeah. Sundar, if you can turn on your mic, you can do that.
Your voice is very broken. You can type your question if you have a little time. We'll try and answer it.
Yeah. So can I speak now?
Yes, you can.
Yeah. So in the good old days, there used to be an approach called prototyping. right? So you do a small prototype and you deploy in a small place or a small segment. Now in the DevOps thing, that still exists, or the prototype is gone, or prototype is part of DevOps? What is it now?
So to answer your question, prototype is very much there. The concept still exists. So now what you if you go to the agile world and all these frameworks, they call it the minimum viable product, right? So the minimum viable product is nothing but your prototype, right? So when you start with something, you have, this is what we can minimum do. This is what we can really show some value and proof of concept. That is a minimum viable product. Sometimes what happens is we learn new things, we call them by the new names, but the concept remains. The prototype very much is there.
Okay, but the tools are now substantially improved to make it actually try.
Absolutely. So
that's a very good. For the earlier question, the end user behavior is different actually, because you could have done it before. That attitude comes in. Yeah, I understand. Okay. Yeah.
Yes. So there are, you see, not a lot of tools available within the clouds. You see, irrespective of which cloud you take, there are so many options available for you to try out something for very, very low cost, right? The prototyping you can do for free today. You create a free account in Azure or AWS or any of the other clouds. You can do your prototype for free also today. So the tools are very much available. The cost of making the prototype has gone down considerably, right? So that's what I first showed you, right? The cost of failure is negligible now. So you can try out new things without the risk of failure.
Thank you, Deepak. Anybody else, please?
I think Balu had one more question. Balu?
Right. Yeah. I'll go for the next one. So development team, right, in the DevOps, right, are also doing the operations work. And in the spirit of fixing the operations, right, don't you think the velocity is actually getting challenged? And their backlog is continuing to be a backlog and never in the front.
Yes. So this is a very good point in terms of how do you make sure there is a balance between building new software and fixing your old stuff. So the way we do it in Microsoft is we have what we call as dedicated roles within the development teams. So which is by rotation. All these roles are by rotation. So everybody gets to play this role of operations for a set period of time, right? So it's not that they are taken away from development work. They're dedicated. Their bandwidth is provided to monitoring production and production issues and keeping the main team. This is what we call as a shield team. So this shield team's job is to shield the rest of the team from getting production issues.
Yeah.
Right.
So with that, sorry, go ahead.
Yeah. So the shield team actually takes the brunt of all the production issues. So they will handle it, try and protect the rest of the team which is working on the backlog, and they will work it. So this is some amount of bandwidth which requires to be dedicated to operations. So instead of distributing it across multiple people who are doing the backlog work, it is given to those dedicated people.
So follow up 2 questions, right?
Yes.
One is with this, right? The context switching becomes much more quicker, right? They kind of go fix the operations versus, they have to come back and start looking at the features.
Yes. So this does not require context switching because those people for that duration. So by the way, we want within the feature team, we want everybody to play that role, because the way you understand how your software work is when you actually see what is happening in production. Right. So this is done by rotation. By rotation, everybody gets to play this role of the shield team. Right. So it's not just that you hire 2 people who are just sitting and watching the bugs. That is not the job. Everybody gets to do it for a fixed period of time by rotation.
Yeah, and then the other thing that you talked about is, I think you talked about the sizing of the team members, which will come a little later. But then you also talked about somewhere on the organizational structure standpoint, right? Earlier it used to be a separated organizational structure. Now you put everybody in the team. But that becomes like, they're not in different management to have different directions, but one single umbrella. But are they continuing to do different roles? Like testing guy will continue to do testing, infrastructure guy does it, and development does it, or are you kind of interchanging
so
that?
that you see, that is what happens in a transition state. When you put those people together, for some duration, they might be doing those tasks which they were doing before. But ultimately, the role of the feature team is that everybody should be capable of doing those things. They may still have specializations, right? They may be subject matter experts in certain areas, but they are expected to, there is no dedicated test role. All people doing a part of the feature team, they have to be able to write code. That is a fundamental requirement. And of course, all organizations, for example, Microsoft, we went through pain to do this actually, because when we merge these teams, not all testing people were able to write code, right?
Exactly.
So there's a transition period for them to start learning new things and be able to code and do it. Even then, some people were not able to do it. Then they have to go find some different other roles to do it. So we no longer have a separate dedicated testing team, right? So that is a big change and investment which we made in people.
Okay. And one last thing is like, how did you size your team?
The 10 to 12 people.
Mm-hmm.
So you see, that is actually that is typical management concept, which is what is the biggest span of control you can have without really breaking you see, if you there are various background to it. If you go to I forgot which company says they have the pizza concept, right? It says how many people can sit and eat a pizza, right? That is the size of the team. So there are some theories around it, but we chose that this 10 to 12 people is the magic number for us.
All right. Thank you, Deepak.
Deepak, let me take one question. You can go back to the L3 testing slide.
Yep. You want to see that?
Yeah.
Okay, let me bring that up. Okay. Right. L3 testing slide.
Yes.
Yeah.
Yes. So the message is very clear here that full environment test is not required as you progress through this. That's what you were saying.
Yes.
Now I wonder something, that whenever you make incremental change to the development of the code,
yes,
do you follow the same process for making incremental change in the test code? I mean, you have to have a test.
Yes. So one thing is very important, which is probably because testing, I can talk about testing just for testing for about 3 hours, right? So testing, the test code is at par with the production code because it is written by the same people. So it is a rule, all code has to be tested, right? So you have to write your test if you have written the code. So it has to be written at the same time. There is no after that. So when you write the code, along with it, you have to write the test.
So what you're saying is that a thing that today, whatever changes you want to make to the already production code, yes, and to test that, you have also taken care of the scenario where you're not going to violate some of the previously established.
Exactly. There's no regression.
Yeah, good. So I think this was wonderful. Now, one comment from you would be appropriate about the applicability of this model of development, because people should not go from this talk thinking that DevOps is panacea in all software environment cases. We can go ahead and use it.
So the applicability, I would say, this can be applied to building a small websites to building a very large software, right? The concept will apply, right? You can do DevOps. The concepts will apply to building a small software. The things which I've talked about, doing this L0, L1, L2, all these tests, you can still do it even if you're building a small website. right? A small website, a single page website, or what is called as the single page application can also, you can apply this to that, right? The tools, the concept remains same. You can still write unit tests for that application. You can still write the integration test. You can still write the load testing. All those things can still be done. And all the same tools are available to you as a small environment, what is available to the big enterprises, right? It's only the level of complexity might be different.
Okay, thank you. From the participants, any other question? We have, we have exceeded our time, but we can still take questions if you have any.
I think JK, Mr. Kumar Biswal, sorry,
Yeah.
had a question. Mr. Biswal, can you unmute yourself and ask if you have a question?
Sure. Jitendra, go ahead.
Oh, okay. Okay. Sorry, I could not follow the whole meeting sessions because of my intermittent meetings. So yeah, I have a fair amount of exposure to DevOps. So my one question is the way the DevOps has come up and it has been become a part of the whole project lifecycle. So do you think there will be any need of a DevOps team? Because I feel it will be a part of the, just like another database developer, it will be another like DevOps developer who will be working with the team. So looking on that particular perspective, so do you still segregate as a separate skill, or do you segregate as a part of a project skill?
No. So within Microsoft, we don't consider DevOps. There is nobody called as a DevOps engineer. So we do not. So this is actually a sort of a misnomer within the industry, I would say. The DevOps means if you go to LinkedIn or any job site, it'll say we are looking for a DevOps engineer, right? So when they say, if you read the job requirement, what they're looking for is a automation and release automation and deployment engineer, right? So that is the industry meaning which has somehow got created. I do not know the background is. So if you today were to hire quote unquote the DevOps engineer, in Microsoft there is no DevOps engineer. We have only engineers, software engineers who basically use DevOps as a method to build software. So DevOps is a method for us. For us, DevOps is not a role. DevOps is not a definition of a person, right? So DevOps is just a method by which we want to build software. So that is the distinction which we make from what you see in the industry, right? And this is what we encourage also. Don't hire DevOps engineers. So the nearest what we have seen is a full stack developer, right? That is closest to what we mean when we say an engineer within Microsoft is a full stack developer, because we expect the engineer to do everything within the feature team.
Yes, I perfectly agree with you. I have another question as a Microsoft DevOps tool as a product point of view. Yeah. Because I'm also using a DevOps quite heavily. And I found, there is a gap of the features, the way Microsoft DevOps has developed from your classic pipelines to right now YAML-based pipelines. So I know that Microsoft is a late starter on that particular point of view.
Yep.
So do you have any kind of like a visibility when the gap will be closed, so that as a Microsoft practitioner, we should be at par with the other tools?
Yeah. So actually, the Azure DevOps team is very transparent with their roadmap, right? So as I said, they deploy every 3 weeks, right? So you can actually go and one is, if you find a gap, there is a user voice option available that you can upvote, because I'm sure just like you, other people have reported that gap to be filled. So they track it, they monitor how many people are requesting for that. That is what, when I said the customer focus, they are very responsive. They publish their roadmap. I can send out a link on this. There is a link which is, you can say Azure DevOps roadmap. If you just put on a search engine, you will get the roadmap link to the most of the features of what they're planning to release. And if you don't find what you are looking for, they are very responsive. You can just go, and if you don't find that gap anywhere listed, you can list it on Azure DevOps user voice, and they will definitely give responses. So that's what we have learned in the last so many years, being responsive to our customers.
Okay, thank you.
Thank you, Jitendra. I think we are already at 6:50. Wonderful interaction by the participants. JK, over to you.
Thank you, Prashant. Hey, Deepak, it was indeed wonderful. Thank you for getting into the details of it, and the kind of interaction you had post your talk. That is the testimony to the interest that you have created among the audience. Thank you very much. For the people, you recommended one book. Now I'm recommending one book here. This is another very light reading book on DevOps. If possible, grab it and enjoy this. So thank you, everybody. Look forward to seeing you for the next talk. It will happen in about 3 weeks from now, and we will be getting back to you with the topic and the speaker. Thank you for today. Thank you very much.
Thanks, everyone. Hey, thanks, Deepak.
Thank you, and see you next time, guys. Bye.